My name is Marco. I work for AWS. I've been in AWS 5 years, and I spent the last 7 or 8 years working on Kubernetes and AKS. Why this talk? If you work in technology or in the cloud, you're probably familiar with the talk scaling up to 10 million users that we normally do at AWS events. And I was looking at it with a colleague some time ago, and we thought it was a good idea to refresh it, focusing on Kubernetes, because most of our customers are using Kubernetes right now. And then we come up with this presentation. Okay. Okay. The agenda is quite simple. So we will be talking about sizing, the common pain points that we see working with customer scale, the possible solution, and some observation. Unfortunately, there isn't a really one-size-fits-all with Kubernetes. So I try to structure this presentation with different scenarios and with different examples depending on your size. But let me start with the presentation. That's it. If you want to reach me after the conference, I'm joking. There might be more, but this is a very key point that sometimes we overlook. When you start to have a certain number of workloads to manage, the first question that pops into mind is how many nodes or cluster I need. And if you look at the left, those are the guidelines from the Kubernetes documentation. So no more than 110 pods per node. I put an asterisk because with the modern version of Kubernetes, this is more a soft limit, but anyway, something you should keep in mind. No more than 5,000 nodes, 150,000 pods, or 300,000 containers, which seems simple, but if you look at the right, there are a number of considerations, you need to take into consideration the blast radius, the SLAs, availability requirement, security boundaries. For example, you need to ask yourself, what happens if one of my clusters goes down? What are my RTO and RPO that I'm guaranteeing to the business? If I have any availability requirement or regional constraints, do I need the cluster during the weekend, for example? Or is my traffic 24/7 or I need to scale up and down? Or do I need specific people to access my clusters or to access specific application? And I tried to summarize this starting by categorizing cluster by number of nodes. I know it's not the universal metrics you can use, it's one of them, but it gives you a good idea of where you are in the journey. And you're probably, when you start to design your infrastructure and your Kubernetes infrastructure, you're probably in one of those two situations. And the question is, where do I start? And from experience, talking with customer, a very good start is start from pod density. So bear in mind that 100% utilization of nodes is impossible. You have daemon sets running, login agents, security tools, and a number of things. And also you should have a little bit of overhead. But still, you should shoot for something that gives you a good utilization of nodes. And of course, you're probably all familiar with it. How can I influence this with Kubernetes limits? Now, I'm not explaining what Kubernetes limits are because everyone in the audience probably knows already, but I want to give you a little insight of what a limit really does on a kernel level. And there is, linked on the slide, there is a very, very good blog post that explains this in details. Unfortunately, I have 30 minutes, so I will try to do my best to summarize it. But when we configure limits, we are telling the Linux node how long a specific containerized application can run during a specific period of time. So when you assign one core to your application, you're not reserving one core into the instance. You're telling the kernel that the specific number of threads or the specific application can run a number of milliseconds up to the consumption of a core. And this is very important because I think we all did it. We start with an application, we guess the limits a little bit, like we are installing Prometheus and we say, yeah, 1 core, 2 gigs of RAM is going to be okay. But if you really look at it, the story is a bit different. And basically, when you're setting the limit, you are limiting how much a thread or a process into the kernel can run before other application need CPU. And I'm focusing on CPU because it's a very simple example and it's very good, but that's exactly the same with memory. So what you should really do before even scaling or before thinking about going above 50, 100 nodes, 200 nodes, is to take some time to understand your application. For example, take your application and try to benchmark it. Does it run better on Intel-based instances? Does it run better on AMD instances? Can I run it on ARM? And if you do this and you take the time to study, you can do then some simple math and understand how much roughly is going to be your pod density, and with some other math you can understand the number of nodes. Number of nodes is something that we use to sort of categorize use cases. So you will see that the presentation is structured with 10, 50 plus or 100 plus nodes. Of course, we will focus more on the 100 plus nodes because the talk is about scaling, but I wanted to provide the exact journey. And those are really, really generic things you should look at. We will dive into some of those during the presentation. For example, we will be talking about DNS, image caching, and a number of other things. The real takeout of this presentation will not be some configuration you can put in core DNS to optimize scale. That's on the internet and you can find it on GitHub. The real takeout should be a list for you of things that you can look at when you go home on Monday and say, am I looking right? Am I doing A, B, C, D on my cluster? Yes, no, or should I? And this is really the takeout because I'm lucky. I have the possibility to work with a number of customers and I speak with a number of customers every day running EKS. So in our position, it's a lot easier to see the gaps. If you're focusing on a single platform, maybe you're doing a number of things and you think you're doing good, but maybe you are overlooking some other aspects. And if you look at the numbers, 50 nodes or 100 nodes, if you think about a reasonable pod density, like something between 50 and 70, we are talking about 3,000 and something pod or 6,000-7,000 pods per cluster, which is not really, really big, but it starts to be a size where you should take those things in consideration. And I will start, for example, talking about DNS caching, because it's one of the topics that we discuss the most with customer. And if you have 10 or less nodes, DNS should not really be an issue. Like if your application is behaving, there is nothing you need to do. I put this because it's a cool feature that we released for EKS. We can do scaling of core DNS for you based on metrics. But again, it's not something really that you need when you have less than 10 nodes. Everything should be okay for you. When it starts to get a bit bigger, so 50 nodes, again, everything should work pretty much outside the box. Maybe you scale core DNS, but if your application is DNS optimized, everything should be okay. However, it's probably a good opportunity to look at the actual core DNS configuration. And there is a config map you can change. There is really a ton of documentation for it, but you can look at some interesting parameter. For example, cache, which is a bit self-explaining. Forward, if you have a set of record or a DNS zone that you know is resolved by a specific resolver, you can hard code it in the configuration, so you go straight to it and you skip all the oops. And load balance is when you have multiple records, multiple hosts on a single record. So core DNS can randomize the answer for you, so you don't need the usual host every time. When you get to 100 plus nodes, things start to be interesting because probably, I mean, for experience, you might have some DNS performance issue. So one thing that you should look into is node DNS caching. And this is the generic description you can find on the Kubernetes documentation. If you're using EKS, probably you want to look into DNS mask, is how most of our customers are doing it. But the idea is to have a local resolver on the node where I can, one, cache maybe the 80% of my records, so the record that I resolve on more often, and as well improve performance, because every time I need to resolve something that is cached, is local to the node, I can put it on etc resolve.conf, and I talk with a local lookback interface. I don't need to talk with my DNS server. So next slide is about networking, and it's a bit complex, so I split it into 3 slides, but it follows the same principle: 10, 50, and 100 plus nodes. So when you have 10 nodes, to be fair, there is nothing you need to do. I mean, this is a nice feature we have, for example, with prefix delegation, but the only thing that you need to do is pay attention to the size of your VPC. Because you start with 10 nodes, but before you realize, probably you run out of space and you start to have 20, 30 nodes, 40. So the only thing that you need to do at the beginning is taking account some growth. Things start to be a bit different when you start to have maybe 50 plus nodes. A cool feature that we do is custom networking in EKS. So basically, we can attach a secondary CIDR to the VPC and schedule all the pods to be in that CIDR. The good thing is that you can use non-routable ones, for example, the CJNAT 1064.0016. And the local node, so the primary interface, acts as a NAT between the two. So from a pod point of view, there is nothing you need to change. There are just some configuration on the node. And you can have the primary interface, so the nodes in your routable space, so your 10 dot or your 172 dots. And at the same time, have hundreds and hundreds of containers that are running on the secondary CIDR without using much space. So this is the interesting one. If you go above 100 nodes, or you are planning to scale, our opinion, the guidelines from AWS would be using IPv6. So VPC, Amazon VPC supports this dual stack concept, so you can run both IPv6 and IPv4 in the same VPC, and at the same way, Kubernetes EKS supports this dual stack mode, where you can have all the pods running on IPv6 addresses, and at the same time have connectivity to IPv4 endpoints and dependencies. And in our opinion, this is really the way to go, because if you do the math, you can have some stupid number like 56,000 pod per node, something like that. That is plenty enough. And still gives you flexibility and full compatibility with the IPv4. Another thing that we often discuss with customer is image registries and pool times. So again, when you have less than 10 nodes, life is easy. You just need to make sure that you use the right base image, because if you run a Python application, probably you don't need the full 2 gigs Ubuntu image, and that you are using proper versioning. But when you start to have more nodes, and especially if you scale up and down, so you have maybe tens of nodes starting at the same time, you start to need to take in consideration different things. One is registry optimization, and with the registry optimization, I mean that you probably want to think where your container registry is. Maybe you are using an on-prem Artifactory or some sort of things that you're using on-prem. You need to start to think if performance-wise makes sense every time to go through the VPN or whatever connection you have with on-prem to pull images. And at the same time, you probably want to do some filtering. So you want, for example, your images to be pulled by a specific registry and not Docker Hub or any other registry. This helps, one, to run governance, and two, to improve security, because most of ECR and most of the modern container registry are somehow compatible with the security scanning, especially on push. So you should scan your images on push and on runtime. When I say runtime, I'm talking about Sysdig, Falco, or Twistlock, those solutions. When you do the next step, so you go above 100 nodes, one thing that we do often is, it sounds stupid, but we work on image deduplication. So I challenge every one of you to log in on your company laptop and check how many Nginx version you have and how many images from 2007 you have. Probably a lot of them. And if you work with very large images, another thing that we discuss is pre-caching of images. Now, I don't really like the idea because I think except if your image is very, very big, doesn't make sense. And if your image is very, very big, probably you should look on why the image is so big. So the solution that we suggest is to use a feature of ECR that is called pull-through cache. It's very simple. Every time an image that is not on ECR gets pulled from an upstream registry, ECR takes a copy of it, and then you can use ECR that is compatible with VPC and has a VPC endpoint. So every time you pull an image, you pull it locally from your VPC, and performance should improve a lot. At the same way, autoscaling, I will go really quick on this because it's a very huge topic, but I wanted to put some of the things that we see talking with customer. When you have very few nodes, you just need to make sure you're using a recent instance family and you monitor the usage. There are a couple of cool projects. One is kube node usage and the other is kube capacity. There are a lot on GitHubs, but those two are really cool. When you get to 50 nodes, probably you want to look into autoscaling, and those are the traditional HPA and VPA cluster autoscaler. Or we have Carpenter. Carpenter is an autoscaler managed by AWS that responds automatically to changes in application load. So every time there is a bunch of pods that are pending, Carpenter provision an instance with you. The difference between cluster autoscaler and Carpenter is that Carpenter tries to give you the instance of the right size for the number of pods that are pending. So if you have a single pod pending with some very low limits, it will give you like a small instance. If you have a bunch of pods or a large number of pods with high limits, it will try to fit them on a larger instance. And finally, with 100 and plus nodes, you should really look into differentiate the instances. So what I mean with that is that one, you probably want to run different instances for different part of your application. And two, that you might want to start to use affinity or anti-affinity or some sort of selector so that, for example, your kube system pods are running on a different node groups or some pods that are accessing and some resources are running on a specific set of nodes. Same goes for spot and GPUs. That's probably something that you want to look when you start to have like 100 plus nodes. And as well, you should ask yourself if everything you have on Kubernetes really needs to be a container. So, for example, maybe you have an API that you call only on a Sunday when you do some batch processing, or you have some conversion service on the cluster that is called really often, that is not called really often. So you should really look into in serverless. I put Fargate, which is the AWS solution for it, or Lambda, even better, because if it's something that doesn't take time and doesn't need to run 24/7, probably it doesn't need to be on a container, or maybe there is no much sense on running it. And if you're looking at it, we have another AWS service that is really interesting in this context. It's called Amazon VPC Lattice. I will go very quickly about it, but VPC Lattice is a networking service that helps you to monitor and set up connectivity between services within your infrastructure, and is compatible with EKS, EC2, and Lambda. So you can have a managed service basically to route traffic across services, which is really cool in those situations. And last but not least, operations. So when you are thinking about going at scale, there is really a lot of homework that you need to do. For example, very important from the beginning is the cluster creation. You need to have a reliable way to create your cluster. You can pick the technology of your choice, Terraform, CDK, EKS, CTL in our case, but it's really, really important that you have a reliable way to create your cluster. Not only because sooner or later you need to create another cluster and install all the dependencies on the system things, but in case of DR. Another thing that you should look from the very beginning is some basic node management, because sooner or later you will need to rotate, patch this node, or deploy new nodes. So that's something that probably you want to look into. And finally, disaster recovery. Architecting disaster recovery from the beginning is a lot easier than having like a 100+ node cluster and then trying to understand all the dependencies and how to do DR. So that's very important that you look into it. When you get to 50+ nodes, things start to be a bit more complex. So you might want to look into dedicated RBAC role. So for example, your developer should not have access to your production cluster, like rule number 1. But also, they should have dedicated roles with just the action that they really need. You should have, this is very important, you should have some sort of reliable way to deploy application. If you create a new cluster, you don't want to get on a phone call with 15 people with 15 different Jenkins pipeline and stay with them until the cluster is redeployed. You want something like, GitOps is the ideal case where you can use something like Argo, and every time you create a cluster, you can inflate application. Something in the middle is good as well, but you definitely don't want to have different people with different systems to deploy application, and you want to make sure that all the applications are deployable at any point in time. So if you have a disaster recovery event or something, you should be sure that everything that is in Git is deployable, and there might be some tweaking required, some restarting required for developers, but you should be reasonably sure that everything you have in Git is deployable and should be trusted. And another thing that we normally do with customer and is a bit overlooked is daemon set optimization. So if you think about your daemon set, there are some of them that are required in each node, like logging, monitoring, those things. But the great majority of them is very, very specific. So a good example is like the NVIDIA driver for GPUs or CSI drivers. They are using a lot of resources, and before you realize it, you are allocating one of them in each node, and it's not all of them are required in each node. So one thing that you need to look at is understand if all the daemon set that you have in the cluster are really required to be on all the nodes. Otherwise, you can use a selector or labels to really allocate them where you need them. And that seems stupid, but it should save you a fair amount of resources. And finally, when you go really big, you should really look into cluster access. So one, you need to understand who really needs admin permission on your cluster, and 2, you should have some sort of single sign-on integration for the cluster. Important as well is change management, because we can have GitOps, we can have all the fancy thing, but then if you need to file a ServiceNow ticket and wait 24 hours for someone to approve it, all of this doesn't really make sense. So you should really work with your business to have like an automated change management, or at least something that is it goes at the same speed of your development. Because the worst thing you can do is put your developers in the situation where they work really hard to deploy a feature, and then they need to wait 3 days for a firewall change and nothing can be deployed. And finally, this is a big one. You need to understand how to manage dependencies. With dependencies, you have an application, for example, that requires an S3 bucket or a RDS database, a DynamoDB table, something. So the ideal case is that you provide developers with a way to manage those dependencies. So there are a number of operators like the Terraform operator, or we have ACK in AWS. But the idea is that you bundle the lifecycle of the dependency with the application. So you expose the applications with a set of CRDs that developers can use. So they can use the same Kubernetes API for everything. They can define YAML files with just a different syntax. And with this YAML file, they can deploy dependencies. This is good for a couple of reasons. One, because it removes a lot of overheads from your operation DevOps team. And two, because then the dependencies follows the lifecycle of the application. Every time you need to recreate a cluster, or you have a DR situation, or simply you add another application to your cluster, you can get the dependencies that you need created together with the application. And at the same time, if you delete the application or you want to move the application, the dependencies moves with it. That is a lot easier than having a team that is creating resources for developers. You will get a number of requests to create all possible resources, and it's very difficult to coordinate. If you think about a good dependency lifecycle and you expose the actual API through Kubernetes, is a lot easier for your developers as well. And I tried to make a summary. Again, I know it was only 30 minutes, so it was very difficult to go really in details in any of those, but those are the really important ones, in my opinion. One, you should treat your cluster as a product. So you should not deploy things or do things for the sake of doing it, but you should have really a roadmap and some product ownership. So you should do proper sprint planning and have features coming to your cluster. So every time there is a feature or every time there is a problem, you're able to track down the original requirement. Or if you do something, you know that there are some acceptance criteria or anything you can look at to see if your feature is fulfilling a request or not. Two, very important, keep it simple. There are millions of projects on GitHub and everywhere on the internet, but the more you scale the cluster, the more you'll find out that sometimes you became the maintainer of the solution you're using, or you ended up forking the solution that is even worse because it's a lot more work for you. Do not assume limit and configuration. We all did it. I've been there. But really take time to understand your application, because if you do it when you have 10 nodes, you can take some time and understand it. When you start to be at scale and in production, there are 1 million more variables, so it's really difficult to do it. 4 is really a no-brainer. Use infrastructure as a code and Git for operation, GitOps. 5, if you are really planning to scale, look into managed services. They might be more expensive at the beginning, but in the long term, they make a lot of sense. And 6, last one, do not reinvent the wheel, because every time you have a problem, especially if you are starting with Kubernetes in 2024, you can assume that someone else on the world is having the same problem, or there is some sort of GitHub thread that is talking about your issue. So before overthinking and doing something very, very complex, look around and see if there is someone that is having the same issue. And that was pretty much it. We will open to question if there is any. If I can ask you, we have a survey to compile. This goes straight to AWS, and I really appreciate if everyone of you can do it. This is the first time I do this presentation, so any feedback is really, really welcome, even if you think that there are things missing or things that could be better. So please scan this and let me know if you have any other feedback.
Thank you so much for your talk. I can give you feedback immediately because I thought it was great.
Thanks.
And I really enjoyed the fact that you said this is how you, like the kind of concerns that you might have as you scale forward. Mm-hmm. So that was really great. Yeah, please make sure to give feedback to our speakers. Put a lot of work into their talks.
5 star.
Think 5 stars. All right, we did receive a couple questions. And the first one is, what is the maximum number of nodes you advise to scale beyond 100? Is there such a maximum number?
I think they misspelled and they mean pods with this, because 110 was the maximum number of pods.
Oh, I thought it was 100.
I'm assuming, I don't know,
okay,
but it's reading the question, and it's a tricky question. There are valid reasons why you should scale and you should have more than 110 pods. In the real world, reasonably, you should really look at something like 50, 60, 70, maybe pod per nodes. There are reasons, and there are legitimate reasons where you need more than 110, but as a rule of thumb, you should start slow, start with a lower number, and then understand if you can really pack more than them.
Yeah, that's a very comprehensive answer. With regard to differentiating instances, at what point would you recommend running observability services on dedicated nodes?
It really depends on the quantity of metrics and things you handle, and also if you need special permission for those services. A good thing that is not only to differentiate instances, but a good thing is that if you have a dedicated node group, you can have different permission on it or different configuration on it. So if you're dealing with maybe some specific IAM roles or some specific permission, it's a lot easier to apply them on a specific node group than applying it to pods that are spread across your cluster.
Yeah. The next one is, how do you make sure controllers like Argo CD keep up in large clusters?
That's a very good question. I mean, one, making sure that they are scheduled on the right nodes. And two, an important thing that maybe was not in documentation, you should also make sure to reserve resources for system components on nodes, so kubelet and things like that. If your node is healthy and Argo is scheduled on a node that is not 100% utilized, it should be okay on paper.
Okay, and the last one is, do you also limit max IO? And if so, how do you do that?
Again, this is really specific. I'm not sure they're talking about networking or storage. I don't know the answer on top of my mind. I need more details.
If whoever asked this question, if you're here, then please pop and chat to Marco at the break. Thank you so much. Let's have one more round of applause for this wonderful session.